Welcome everyone to the class of computer network. In this class, we will start with network devices. So these are basic terminologies that we are going to use frequently in the upcoming lectures. So let me first introduce the different network devices. Okay. So number one that I'm going to discuss is host. Number two is IP address. Okay, so majorly there are certain terms and certain network devices that we are going to discuss over here. So initially there are three major terms that we are going to use in the computer network. So first, before actually discussing the network devices which are actually practically used in the computer network, we are going to first understand the terminologies, the basic terminologies, and we will start with the host. So let me introduce what is a host. So, hosts are any devices which actually sends or receive network traffic. Okay, that means anything that can send the traffic, or you can say the data on the network, is called as host. For example, let's say you're having a computer that can be a host. It can be a laptop, it can be phone, printer, server, or you can say in nowadays we can say it can be a cloud server. Apart from this, a host can be, you know uh, your IoT devices. For example, let's say you have a smart TV, or you can say anything, speaker or refrigerator or fan, lights, anything. So all these are called as hosts because all of these having a capability of sending and receiving the traffic over the network. For example, you can, your refrigerator might tell you that this much quantity of milk he has or something like that. Okay, or you may have, a smart TV that you are using. So that is actually going to send and receive the traffic over the network. So you're familiar with the term now. The what would be the host is. So these are the hosts, and if I if I go further in the detail of host, so host can be of two types, or you can say we can further categorize the host into two terms. One is client, another one is server. Okay, so client would be the host which actually initiate the request, and server are nothing but the host which actually respond to that request. So for example, let's say if we have a computer which is requesting a website to open, let's say this is a web server of www dot, let's say anything site.com. Okay, so let's say this is your client because it is requesting, you can say it is initiating the request to open a website, any website. Now it is connecting to its web server, and web server is going to respond to this request and sending the way how to open a web page. So in this case, this would be a client and this would be a server. And in broader terms, both of these are host. Now, one thing that you need to be cautious over here, that the term client and server are nothing but specific to the particular communication. For example, let's say we have a communication in between this computer and this web server. Here, this computer is a client and this web server is a server. Now, if we look at, let's say in the same example, if this web server is trying to update some file, or you can say it's trying to connecting with some database server or some file server for updating some file, then in that case this web server is initiating the request and this file server is actually responding to that request. So in that case this would be a client and this would be a server. Similarly, let's suppose this file server needs to update some software, and here it is one update server. So let's say this file server, this system file server is actually requesting to update certain software, then in that case this would be termed as client, and as because this update server is responding to that request, this would be server. So this is how the terminology of client and server changes uh, depending on the scenario basis. The overall thing is client, which actually initiate the request, and server is nothing but to respond to that request. So this is what the basic number one terminology that we are going to use in the upcoming lectures frequently, which is host. So I hope you got the point. You by this you got to know what is a host and what is client and what is a server. Okay. Now we will see next, which is IP address. IP addresses is nothing but the identity of each host in the network. Okay, that means that every host in the network is having an IP address, whether it is client or server. So let's suppose in a network, whenever a client want to send a web request, or let's say if it is a web server, so whenever the client is sending a request to this web server, then it is sending a packet, and that packet will actually include a source IP address and a destination IP address. The source IP address would nothing but the IP address of its own, okay, where from this packet is actually generating. Okay, that means जब भी इसको एक कम्युनिकेशन करना है इस होस्ट को, होस्ट नंबर वन को होस्ट नंबर टू से, तो ये क्या करेगा, एक पैकेट जनरेट करेगा। इस पैकेट में कुछ इन्फॉर्मेशन होगी जो कि सोर्स आईपी एड्रेस और डेस्टिनेशन आईपी एड्रेस की होगी। सोर्स आईपी एड्रेस इज नथिंग बट द आईपी एड्रेस ऑफ इट्स ओन, एंड destination IP address would be the IP address of this web server. Okay. Similarly, whenever this server needs to respond to this request, वो एक और पैकेट जनरेट करेगा और उसमें भी इंफॉर्मेशन होगी सोर्स आईपी एड्रेस और डेस्टिनेशन आईपी एड्रेस। नाउ द सोर्स एंड डेस्टिनेशन विल interchange. Now this is actually source because it is responding to the packet. Now it is generating, as because it is generating the packet, so now this would be the source and this would be the destination. So source IP address would be now 192.35.33.1, and destination IP address would be 132.55.2.1, like this. So this is one clarification about the IP addresses. Okay. Now, if we further look into the IP address is nothing but the 32-bit address. 32-bit means it can be a sequence of 32 1 and zeros, like this. But as because these 32 bits, would be quite difficult to memorize, or you can say to recognize as a sequence whole. So it is being divided into 4 octet, and for the simplicity purpose, a chunk of this whole 32 bits is being divided into chunks of 8 bits each. And out of this, this 8 bit is separated with a dot, with this 8 bit again a dot, then this 8 bit, then again a dot, and final the last octet. So there are 4 octets you can see over here, and all the octets are separated by the dots. This is what we call the dotted notation for the IP address. Now, as because you can see that this chunk, or this you can say this octet is having a range of, can have minimum of zeros. If I fill it all by zeros, all the 8 bits when we fill by all zeros, then it will give the minimum value, which is 0. And if I fill it by all ones, then it will give you the range maximum, which is 0 to 20 to 255. So that's why you can see always that this will be in a range of, all the octets would be in a range of 0 to 255, and hence this is how you can see that IP addresses will look like this. This would be something one, let's say 153.254.33 dot and 92 something. So anything which comes into the octet, okay, is having a range between 0 to 255. Now there is one more thing that we will clarify over here, and that is the IP addresses are nothing but the hierarchical addresses. Okay, so this IP addresses are actually assigned. These are hierarchically assigned, and it is something by a process of subnetting. Now, as of now we are not going to discuss the subnetting over here. That subnetting part we will discuss in the detailed section of IP addresses when we will discuss the network layer. So by just if I give you a brief introduction of the hierarchical addressing scheme of this IP address, or you can say how the IP addresses are hierarchically assigned. So let's say we take an example of a company. So let's say some company is XYZ, and this company is having an IP address of, let's say, 20 dot, that means 20 dot anything after the 20. Okay, so anything can be come in the place of X. So it is 20 dot something. Okay, or you can say 20 dot anything. That is the IP address of this company XYZ. Let's suppose this company XYZ is having a branch in its India office. Let's say it is having further branch in its US office, and is having the next branch in, let's say, London office. Now this India office can be have the IP address 20.10 like this. This US office can be 20.20 x.x, and then this London office can be 20.30.x. Further, this India office is having certain different departments. So let's say if it is having the sales department, so that is having, let's say, further. So this is what the sales department is, and let's say another department is marketing department, and the further is production department. So let's say this marketing department is 20.10.66.x, and production department is 20.10.77.x. Similarly, in the US office, let's say the same three departments this the company have. So it can be 20.20.55.x, and for the marketing, we have 20.20.66.x. This will be 20.20.77.x. Similarly, in the London office, 20.30.55.x for the sales department, 20.30.66.x for the marketing department of London office, 20.30.77.x. This would be production department of London office. Now, just by looking at any IP address, for example, let's say if we have an IP address 20.30.66. 132. Okay, so let's say if we have an IP address this, so just by looking at this IP address you can get to know that this IP address can be a host from the company XYZ and its London office and its marketing team, and it can be a host from the marketing team of the London office of this XYZ company. Okay, so that is why this hierarchical addressing is being, or we can say the addresses are being assigned hierarchically, so that they, that hierarchy will give you certain information about the host also. Okay, so just by looking at the IP address, you can get the exact details of the host. Okay, so this is what the general introduction of IP addresses. Now we will see that all the hosts, let's say we have, now we have seen, as of now we have seen the host and the IP addresses. Now if I what I want to clarify over here is something, that every host, if we So now, if any host wants to communicate to the different hosts, then we need a network. So a network is something that helps you to transport the traffic between the hosts. So if there are there can be multiple hosts in a network. So it is something which is essential that is required to communicate to each other. So any two hosts, if they want to communicate to each other, then they need a network. Then there would be a network. Now uh, you can see over here, uh, there is one thing that you can have. Let's say we have a home Wi-Fi. We have a computer connected to that home Wi-Fi. We have a printer. We have a mobile device, your laptop, anything. Okay, so let's say we have this home Wi-Fi over here, and all of these devices are actually performing the same task, almost similar task, that every device is checking the email, every device is looking for some website to open or something. Okay, so this logical grouping is being made for the network, and we have called it the home Wi-Fi. Similarly, let's say we have something over let's say a coffee shop, and where at the shop, if whenever a customer comes, his mobile device, his laptop, or his tablet or something, okay, that is also connected to this coffee shop Wi-Fi. And again, this is a further the next logical grouping of all of those devices. Now, just because of the location difference, because this is at home and this is at some coffee shop which is at the distant place, then these are divided into two different networks. Okay, let's suppose there is one university. University has its own network, and in the university we had different departments, as we discussed an example of company XYZ over there. So let's say different department have their own uh, logical grouping of the networks. So this is department 1, department 2, something like science department, mathematics department, biology department, or something like this. So let's say we have this, we can have this logical grouping of the network also. Now, this you can see over here. Let's say by sitting in a coffee shop and you want to have, or you can say want to connect to the biological department of this university. In that case, similarly, to each network, if we want to communicate to the different network, then either you have the direct connection between all the networks, or there is one way, there is other way, that all these groups of networks are connected to internet. And internet is something which is the group of inter networks, or you can say the different networks connected to each other. Okay. So network of network is nothing but the internet. This is nothing but the internet. And you can see this internet is nothing but the grouping of these all networks altogether. So this is what the network is. Here we have seen this, you can see that we have the main network and we have the sub networks also, okay, for the different departments. So a network can have subnetworks. So this is the basic, the terminology that we are going to use in the about the host, about the IP address, and about the network. So I hope you got the gist of uh, what are these terminologies. Now we will see certain network devices in the upcoming section.